Hello everyone, my name is Nanyu Xu, Nancy. Today I'm going to present topic chapter 4, probability 4.5, conditional probability. And for this course development, my target student is for grade 11 students in starting high school. The textbook we are going to use is Pearson Ethical International A-Level Statistics 1 student book. I have 6 learning outcomes for today. So after this class, students are able to define the concept of the conditional probability. They are able to explain the significance of conditional probability in statistics. They also understand how to calculate conditional probability using formulas and examples illustrated during our class. Critical exam and evaluate the assumption and limitations of conditional probability in various contexts are required. And they are also to develop problem-solving skills by applying conditional probability to novel situations and real-life problems. They also need to understand the relationship between conditional probability and independent events. My context for this class have 4 parts. The first part is review. We are going to review the knowledge from 4.3 and 4.4, since we are going to, for today, is 4.5 knowledge. The second part is introduction. We are going to introduce what is the conditional probability and how we illustrate it, how do we understand it and apply it. And we go to application parts, is our third part. In our third part, the application part, we are going to have 2 examples to show in this class with some sub-questions for students to understand how to use it in our exams and in our real life. The last part is summary. We summarize the whole class we are going to talk about. Okay, so let's go to my first part, is review. In 4.3, what we learn? We learn mutually exclusive events and independent events, right? Okay. So for mutually exclusive events, the probability of A or B equal to the probability of A plus the probability of B. And what is the definition? Everything in A is not in B, since 2 events cannot occur simultaneously. From the Venn diagram, we can see, since the closed circles do not overlap, we have 2 circles, the blue circle A and the orange circle B. And the circles do not overlap, and there's no intersection between circle A and circle B in the Venn diagram. We can just use a simple addition rule to work out the combined probabilities, which we combine the probability of A plus the probability of B. And we also learn for independent events, the probability of A and B equal to the multiplication rule for probability of A multiply the probability of B. One event has no effect on another, they are called independent. From the Venn diagram shown here, if A and B are independent, the probability of A happening is the same whether B happens. We can apply the multiplication rule to determine whether events are independent. That's we learned from the chapter 4.3. And continue with 4.4, we learn the set notation. The first notation we learn is intersection. A intersect B is equal to probability of A times probability of B. And if the 2 events A and B are mutually exclusive, like we reviewed in 4.3, then their intersection is empty. It's an empty set. The second notation we learn is union. The event A or B can be written as A union B. If A and B are mutually exclusive, then the probability of A union B equal to the probability of A plus the probability of B. The last notation we learn is complement of A. The event, not A, can be written as like A prime. And how we read it? We read it called the complement of A. And how we calculate it? The complement of A equal to the 1 minus probability of A. And we have to notice that events A and the complement of A are always mutually exclusive. And here we go into for today's part, introduction. Before my introduction, I want my students to think about one question. How do we understand the probability of an event can change depending on the outcome of the previous event? So think about one question like, the previous event you happened or previous event occurred, happened the current event you are doing or happened to our current situation? I would like to my students to think about one question. What is he doing? He's sleeping. And the probability of you being late for school may change depending on whether you oversleep. And we can see that is his test scores. And we can see the probability of a student doing great job in his statistics exam, depending on whether he prepared well or listen carefully in his class. If you listen carefully in this class, you will get the probability of you get higher score is increasing. If you didn't listen carefully in this class, the probability of the probability of getting your grade score will be lower. And this man wants to have more money in his work. And the probability of Jackie gets higher salary at the end of the year, depending on how much effort he puts before in this year. Therefore, we define the concept of conditional probability. The conditional probability is the probability of one event given that another event, which is our conditional event, has already occurred. The conditional probability of A, given that an event B has already occurred, or known as is denoted by P, A given B. Similarly, P, A given B not, which is P given B, P given the complement of B, describes the conditional probability of A, given that an event B has not occurred. And from the Venn diagram, we can show it. And we move to our calculated formula parts. Let A and B be two events with the probability of B greater than 0. Then the conditional probability that A will occur given that B has already occurred is defined to be the probability of A given B equal to the probability of A and B divided by the probability of B. Note, the above expression follows that the probability of A and B, which is probability of A intersection B, equal to the probability of A given B times the probability of B, known as the multiplication rule. And we can see the calculation probability formula here. We have like P, the given B is the vertical line after it, and we want to find the conditional probability A is before this vertical line. Is equal to the P, A intersection B divided by the probability of B. How we read it? If A and B are two events in a simple space S, and the probability of event B greater than 0, then the conditional probability of A given B is probability of A and B divided by the probability of B, denoted by probability of A given B. The line vertical line, the small vertical line, it stands for indicates the given or on. We can read the probability of A given B, the probability of A on B, like this. And there's also a small part of it, the relationship between conditional probability and independent events. From previous, we get for independent events, the probability of A intersection B equal to probability of A multiple the probability of B. An independent event occurs when the outcome or condition of the previous B or subsequent A event has no being on either. They are independent. So we have the formula. The probability of A given B is equal to the probability of A given the complement of B equals to the probability of A. The probability of B given A equal to the probability of B given on the complement of A equal to the probability of B. And we are going to move our application to see the examples and how we apply the conditional probability in our real life. Let's move on to our example 1. Like our MED program has a total of 95 students in the spring term in 2023 this year. 6 students are enrolled in geometry course with Dr. Mark, and 30 students enrolled in mathematics alliance course with Dr. Ho. On the other hand, there are 25 students who are taking both geometry and mathematical analysis. If we randomly select one student from the MED program, my question is, find the probability of a student from MED program is taking MED 5033 geometry course with Dr. Mark. Like we want to find how the probability of students taking geometry from the MED program. What is my first step? To facilitate our thinking, we can draw a Venn diagram with the circles intersecting each other. Since we only have 2 events happened, which is geometry, mathematical analysis, and taking both. It's only 2 events, so we are able to join the Venn diagram. Like here, this light blue rectangle stands for there are total 95 students in MED program. This orange circle stands for students who are taking geometry class. We have 60 students here. And this blue circle stands for the students who are taking mathematics analysis class, which have 30 students here. For students taking both geometry and mathematical analysis, which is the G and A, which J intersection A, J and A intersection, we have 25 students here. That's how we understand this Venn diagram. And so far, so good. And this step 1, we find the set notation. We want to identify the events. How many events we are going to use in this case? We use the letter G equal to the event that students choose to take geometry course. And A stands for event that students choose to take mathematical analysis classes. And my step 2 is determine the given information. For this information, we are giving there are total 60 students enrolled in geometry courses, and there are total 95 students in our MED program this year. So what's happened next? Is step 3, list the required probability formula and calculate it by substituting values. As soon as we get values, we want to find the probability of geometry class with property of G is equal to the partial divided by the whole. What is the partial? The student take geometry classes, which is 60, and divides by whole class. The whole, how many students in the whole class? In the whole program, 95, yeah. So that will be 60 divided by 95, which is 0.639. And the last part, we interpret the results. Therefore, the probability of a student select from MED 5033 taking geometry is 63.2. And move to our part B. Find the probability that the students we select is taking mathematical analysis with Dr. Hu, given that the student is also taking geometry with Dr. Mark. The step 1, determine the given information. What is the given condition B? So in this case, we are aware that we are going to use the conditional probability since we are giving like the students we select is taking geometry class. That is a conditional event since it has already occurred. What is the conditional probability we are looking for? The student is taking mathematical analysis. That is a conditional probability we are looking for. And A will occur given that B has occurred. We list the required probability formula by given conditions. P of a given G is equal to P A N G divided by the probability of G. G has occurred, geometry occurred, and A mathematical analyzed as a conditional probability. The step 3, we calculate the formula by substituting values. And we get, after substituting values, we get 0.417. And we interpret the result. Therefore, given that student select is taking geometry course, the probability that he is also taking mathematical analysis is 41.7%. That's all. So far, so good. Okay, so we have an in-class exercise try to by yourself. Find the probability that the students we select is taking MED 5033 geometry course with Dr. Mark, given that the student is also taking MED 58821 mathematical analysis with Dr. Hu. The step 1, we always determine the given information. What is the given condition? The student we select from mathematical analysis course. That is given condition. We are giving A. And what is the conditional property we are looking for? The student is taking MED geometry course. With G, we are looking for G, given A. And then we list the required probability formula by giving conditions. P of G given A equal to PG and A divided by PA. A occurred, G as conditional probability. And we calculate the formula by substituting values. Right here, and we got 0.833. We interpret the result. Therefore, given that the student select from MED 5821, the probability that the student is also taking geometry MED 5033 course is 83.3. So far, so good. Okay, we are going to try to sum up or try to find out some general application techniques. Will be our analyzation one from the previous example. The first step is we identify the events or find the set notation. We assign the symbols or letters to these events. Like in the previous examples, we assign G as students who are taking geometry class and A as students who are taking mathematical analysis class. Step 2 is determine the given information. We are going to for the conditional probability. We want to find what is the given conditions, which is behind the short vertical line. What is a given condition? And what is the probability of the result we are looking for, which is before the small vertical line. The conditional probability A will occur given that B has occurred. B occur first. And step 3, list the required probability formula by given conditions. The probability of A given on B equal to the probability of A and B divided by the probability of B. Step 4, we calculate the conditional probability formula by substituting values, and that's how we calculate it, and that's just like use numbers for calculating. Step 5, we interpret the result. We see from the result or from the number we got from the step 4, how we express as our last step. And that's all. That's the 5 steps we calculate for conditional probability. Sometimes steps 3 and 4 can combine together, and step 1 and 2 can combine together. What is the most important part is how you identify what is a given condition and what is the result we are looking for. Okay, so let's see example 2. Suppose HKUST registration office department consists of 48 staff, 15 of whom are women and 33 of whom are men. Of the men in this department, 8 are science majors and 7 are arts majors. Of the men in this department, 23 are science majors and 10 are arts majors. Construct a contingency table first. So for this contingency table, we are giving woman stuff and man stuff. And with science majors, for women have 8. For man science majors, they have 23. For women with arts major, we have 7 here. For men with arts major, we have 10 here. And we calculate the row total. There is total 15 women stuff and 33 women stuff. And there's 31 science major stuff, and there are 17 arts major stuff. The total is 48. We have 48 stuff total. Let's see my example 1. Find the property of a staff with science majors. It will be more clearly with this contingency table. We find the set notation like in these 4 events. W stands event for the staff is a woman. M stands for event that the staff is a man. S stands for event that staff is a science major. And A stands for the staff is an arts major. Step 2, we determine the given information. In this case, a total of 38 staff. 8 women staff with science major and 20 men staff are science major. So we have 31 staff total with science majors. The step 3, we list the required property formula and calculate by substituting values. We use partial, like the previous one, we use partial divided by the whole, which is 31 divided by 48, we get 0.646. The last part, we interpret the results. Therefore, the property of a staff selected from registered office with science majors is 64.6%. So far, so good, that's all. And let's move on to part B. Find the probability of a staff is a woman by giving major its science. What is the given condition here? The staff we select is a science major. And what's the property we are looking for? The staff is a woman. Sorry. So step 2, we list the required property formula by the given conditions. And step 3, we calculate it. We have the property of woman giving science majors equal to the property of woman and science major divides the property of science majors. We get 0.258. We interpret the result. It's giving the staff select with science majors, the probability that the staff is a woman is 25.8%. Find the property of a staff with arts major by giving the staff is a man. In class exists, try it by yourself. Step 1, we are going to determine the given information. What is the given condition B? The staff we selected is a man. That is a condition event since it has already occurred. What is the conditional probability we are looking for? The staff is an arts major. That's the conditional probability that A will occur given that B has occurred. I will asterisk speed here. Step 2, we list the required probability formula by giving conditions. Step 3, we calculate the formula for it by substituting values. We have the P with the property of arts major, given that he is a man, the staff is a man, equal to the property of arts intersect the man, which is the property of man with arts major divided by the property of man, equal to 0.303. And step 4, we interpret the result. We see that, therefore, given that the staff selected is a man, the probability that the staff is an arts major is 30.3%. We have general application techniques 2, analyzation 2. From the previous one, our example 2 and the example 1, how we get it? By creating a contingency table, we can get the union of 2 events directly. Yeah, we can see the row total and column total. We can get the union like directly. find how many students, how many staff. By comparing with the Venn diagram and the contingency table, we are determining the probability of union of the two events more clearly. And the last test is here. In our future class, we will develop the features of contingency table with the frequent distribution of two or more categorical variables. That in our future class, we are going to talk about in the next few classes. And for part 4, summary, we are going to sum up what we have learned today. The first one, define and explain the concept of conditional probability. I will choose one student to answer it. What's the definition? Conditional probability is where the probability of an event happening can vary depend on the outcome of a previous event. The second part, we understand how to calculate the conditional probability using formulas and examples illustrated during class. The probability of A given on B equal to the probability of A and B divides the probability of B. Understand how to express the conditional probability with Venn diagram and contingency table. In part A, we use the Venn diagram since we have drawn the two circles and with their intersection union. And for example 2, we use the contingency table. For contingency table, we have man and woman in our row, our column, and with science major and arts major in our row. In the next class, we are going to talk about how conditional probability related to the Bayes theorem. So first, we will illustrate the Bayes theorem first, and then we'll illustrate how to apply Bayes theorem to calculate conditional probability. That's in our next class, we are going to talk about it. Okay, don't forget today's homework. We have used textbook exercise 4E. Since it's our 4.5, we have question 1, 3, 8, 9 for you to practice. Also, in our real exam collection, you have to do page 45, 49. That's the real exam problems from previous A-level exam. And thanks for listening. That's all. And that's my presentation. And thanks for listening.